email till this morning.
Okay. So yeah, somebody asked on the email. I mean, I sent an email to you guys last night, but it was kind of late. I figured most of you wouldn't have gotten it anyway. But there is an awesome website called coolmath.com, and if you go to that, I'll write it up. Can you see? I can't see. I can't go beyond that. I'll write it up here. Okay, so you can go to www.coolmath.com, and on the left-hand side, it's like there's lots of color on this website. You click on algebra, right? And then you click on exponents. And this lady has written this textbook in total non-traditional format. Okay, so it's not like, you know, the processes of mathematics is to take this and that and whatever. She doesn't do that. She talks like us. She talks like average people, actually even
like
worse. And she writes it, you know, in with her hand as opposed to printing it out. And it's really, really helpful.
So it's not like this accident, but it's like yada yada thus yada yada therefore.
Yeah.
It's like, oh my god.
Yeah, when she talks about an X, she'll talk about, look at that dude, or look at that little guy. And he's, you know, you add this guy to that guy, and he's, you know, it's cool. It's actually cool math. I wonder where she got the topic, the title, Cool Math. That's how she got it, coolmath.com. Anyways, this is not supposed to be an advertisement on my video, but that's okay, I just did it. So, but that is an awesome resource. I really highly recommend you guys use that website to understand concepts better, because she will use colors and break things down in ways that a lot of textbooks do not do. And it's much more enjoyable to read, and it's much clearer for a lot of people. So, what we're going to talk about today is exponents. First of all, we have to understand what an exponent is. Okay? And I think most everybody in here knows what an exponent is, but we're just going to be sure. If I say 4 cubed, does that mean 12? How many people think it means 12? Raise your hand.
Just kidding.
Put that in. Right? It does not mean 12. It means this number times itself 3 times. So we're going to do 4 times 4 times 4. That's what that means. All right? Now, as silly as it sounds, you guys do this all the time. You do 3 times 4 is 12. And I get them on the homeworks. I see them. So there's my first rule. Never, ever, ever, ever multiply exponent times the base. Never, ever, 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 ever. Never, ever, right? How could I be more clear in that? No, you guys got it, right? Never do this times this. It never works. You will always get the wrong answer. Even if you're lucky, you'll be wrong. Right? It's not going to work. So don't ever do that. So now what if I said this? What if I said 1/2 cubed? It's going to mean the cubed, the exponent, says I have to multiply 1/2 3 times, times itself 3 times. So it's going to be 1/2 times 1/2 times 1/2, right? You guys get that? Makes sense, right? You're all with me? Now, what about this? What if I said -5 parentheses squared? So what would it be, Sal?
It would be -5 times self.
Right, exactly. Notice what the 2 is next to, because it's what the exponent is next to that matters what you do. It tells you what to do. The exponent only affects what it's next to. What is the exponent next to? The parenthesis. That means everything inside that parenthesis is what that exponent affects. Everything. It's next to the parenthesis. Everything inside this parenthesis is affected. Therefore, this is equal to -5 times -5 What is a negative times a negative, first of all?
Positive.
Positive. And what's 5 times 5? So the answer is 25. Right? Everybody gets that, right? Pretty straightforward. All right, now what about this? Negative 5 squared. Now, a lot of people would think, oh, that's the same thing. It's not the same thing. You have to ask yourself always, what is the exponent next to? The exponent is not next to a parentheses anymore. It is next to a number 5. It is not next to the negative sign. It is next to the 5. It does not affect the negative sign. It is not squaring the negative sign. It is not touching the negative sign. It is not doing anything to the negative sign. It is not touching the negative sign. Is that clear?
Yeah.
It's only touching the 5. Therefore, the negative sign stays, and then it's 5 times 5. 5 times 5, which is equal to negative 25. Do you see the difference? If you understand this, it makes a huge, huge difference. Because you're going to see these a lot. And Saxon loves to give you these things where they're hoping that you'll mess up on it. Not hoping, but you know what I mean? That's just,
Hope you mess up.
it will, yeah, in a way, they try to trick you. But it's so that you'll learn. Okay, so you guys understand exponents then. Okay, so I think I can move on to the actual product rule of exponents. Now, I've never used colors before on the video, so I hope it works. All right, so let's say we'll use green. So let's say I have an x to the 4th times, let's say I have an x to the 6th. All right? And I want to know, can you see that? I hope, please. It looks like you can. Okay. So I want to know what that equals. Well, I'm going to teach you, or many of you probably already know it now because you did the lesson last night, but algebra is all about shortcuts. But if you forget the shortcut, use what you already know. You guys all know what that means. And so you rewrite it out. For the long way, if you forget the shortcut, the long way is this. That means x times x times x times x. You guys agree with me? That's what that means, right? All right. Times. And then this x to the 6 means x times x times x times x times x times x.
That's x.
Right? There we go. You guys agree with me?
Yes.
This is a shortcut for this, right? I'm so grateful that they decided to make this make a shortcut to this, right? What if I had x to the 210th power times x, to the 497th? I'd be here all day writing my x's, right? Thank God there's a shortcut for writing this. There's a wonderful shortcut. Now,
No, but there's no really shortcut for doing it.
what does this equal? It equals, I'll use black for this one. It equals x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X to the 10th power. All right. Now, what's the shortcut? You guys know the shortcut? Okay, Sal, what is it?
Add the exponents together.
Oh, well, this is intriguing. Look at this. Look at this. I'm multiplying an x to the 4th times an x to the 6th. My x is my base. Do you guys know that? I didn't mention that.
Yeah.
My x is my base, right? And as long as the bases are the same, in other words, they have to both be x's, or they have to both be y's, or both be m's, or both be t's, but they have to be the same, whatever they are, right? As long as the bases are the same, in this case they're both x's, I can, and I'm multiplying them, and they both have exponents, and I'm multiplying them. All I have to do is I have to add the exponents, right? So it's going to equal this, x to the 4 plus 6, which is x to the 10. And look at that. That's awesome. That's awesome. Right? So it makes sense? So let's try another one. Let's try, we'll try red and blue. Let's try, let me think.
Oh, up here.
Let's try x to the 14th times x to the 22nd. Now, I'm sort of glad I don't have to write out x times 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 x. I don't know if I did it the right number of times either, right? Times x 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 times dot 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 times x, right? So I'm glad I don't have to do that. I can use my new little thing here. Oh, I'm multiplying same bases, they're both x's. The exponents are 14 and 22. I can use I'll use my green this time. X to the 14th plus 22, which is x to the 56, right?
36.
I was just checking. I was just keeping you guys on your toes, right? That's what math teachers always say when they screw up, right? Yeah, that's what I was doing. Okay, so there we go. Can you see that? Right, it makes sense. Right, it makes sense. It's totally logical. This is a shortcut. But if you forget the shortcut, do it the long way. You know? So, here's the rule. I'm going to write the rule now. This is the rule. Yeah, okay. X to the m times x to the n is equal to x to the m plus n. I was trying to remember which variables to use. It doesn't really matter. All right, x to the m times x to the n is equal to x to the m plus n. Very straightforward.
Those aren't like terms, so it doesn't work.
Well, they both have the same bases, right?
Oh, so it's x, m, n.
Right? So as long as they have the same bases, they are like terms in exponents, right? I mean, they're technically not like terms. Actually, I should revise that. They are not like terms, but when you're multiplying exponents, they don't have to be like terms. They just need to be the same basis, right? That's the correct way to work. Like say it again. Yeah, like terms matters when you're adding or subtracting, right? But when you're multiplying and dividing, you don't have to have like terms. You'll get very good at unlike terms this year, guarantee. Amy?
I have a question about like the exponents. If it doesn't have an exponent after like the x, like if it's just x times x to the fourth power, you have to add 1 to the 4, right?
Yes. Yeah, that's a great question. So
Like I was confused about that.
So yeah, great question. So let's say you have this. Let's say you have x times, can I use one color? I can use one color, right? Can you see it? X times x squared times x cubed. All right? So some people would say, oh, well, this one doesn't have any number after it. I can just make it disappear. Right? I can erase it. Oh, yeah, you know, you're right.
X to the first power.
X to the first power. I'm going to multiply x.
To the first power.
Yeah, I guess I'm going to just keep it. Any variable that does not have an exponent does have an exponent. And it's always 1. Always. If there's a variable and there's no exponent after it, there is an exponent. It's 1. So then, what is my answer? It's going to be x. They're all the same bases, right? So I know I can just add the exponent. So it's going to be x to the 1 plus 2 plus 3, which is equal to x to the 6th. Right? Great question, Amy. Thank you. Now, what if I gave you this, though? What if I gave you this? X to the 12th power times x to the minus 7. Ooh.
Oh
Now, did Saxon introduce you to a negative exponent?
No.
All right. So a negative exponent, you're going to get to know this, but I'm not going to go into details in terms of what that means right now. You will soon. Well, I don't know. I'm not. When I usually teach all my exponent rules in the same week or two, but Saxon does it differently, so I'm sort of going by their schedule. But x to the 12th times x to the minus 7, it's still same bases, right?
Yeah.
And it's multiply, right?
Just add.
So I have to add, I can do the
Plus
same thing.
-7.
So yeah, so it is equal to x to the 12 plus a negative 7. But do I need plus negative?
Yeah.
Couldn't I just say 7 minus 7? Plus a negative 7 is the same as saying minus 7, right?
Yeah.
Right? Same thing. So I like to keep it simple. I don't like the parentheses. I don't like the extra parentheses. To me, this is simple. When I start getting all these extra parentheses, for me, that's complicated. Right? I like to get rid of all my parentheses before I combine. So, does everybody understand? So it's just going to be x to the 12 minus 7, which is x, which is x to the 5th, right?
Yep.
Right? So what if I gave, now we're going to make it a little harder. What if I gave you, can I erase? I'll erase this one. Can I erase this? What if I gave you this? Let me use a black again. What if I gave you, actually maybe I'll use colors because I use green and orange. All right, let's say I did x times x to the 5th times y to the 7th times y times x to the minus 2 times y to the minus 3. All right. Remember the rule. I have to have the same bases before I can actually multiply the exponents. But they don't all have the same bases. So I can't just say it equals something to the 1 plus 5 plus 7 plus 1 minus 2 minus 3. I have to separate the ones that I have to keep the x bases apart from the y bases, right? So really what I'm going to do is in my brain, I don't necessarily do this. If this is helpful to you, that's fine, but I'm going to show you what my brain is doing. My brain is saying this, oh, well that's going to be x to the 1 times x to the 5, and then times x to the negative 2 times, this is what my brain is doing, y to the 7th times y to the 1, right, times y to the negative 3. So my brain is saying, okay, I'm only going to add the exponents of the x's together to get an x value, x in an exponent. And then I'm going to take the values, exponents of the y's, and add them together. So I've got x to the 1 plus 5 is 6, minus 2 is 4. So I'm just going to go x to the 4th times y to the 7 plus 1 is 8, minus 3 is 5. So y to the 5th. Right? And that's my answer.
That's the simple part.
Does that make sense?
Or just x to the 4th.
Oh, because that really confused me at home.
Right. Now, do I need to have that dot there?
No.
With variables, I don't.
It's just
I can,
plus.
but you don't need it. Whenever you have variables next to each other, it automatically assumes multiplication,
Like on
right?
Saxon last night, they had all those, the x's were all next to each other, and that meant, I was entirely sure that meant times because they were variables.
Right. As long as they're next to each other and there's nothing between them, that means times, multiply. Okay? So, is that pretty clear? I think that's all I need to say on this lesson. Fist to 5. I just want to know how well you guys are getting it. Making sense? Awesome.
Oh,
All right, that's fine. You just need to practice more to get it up to a 5.
Wait,
That's all.
when are you going to explain that? Why?
Awesome. Okay, so I'm gonna stop that lesson.